Here we are discussing area of a trapezium. Trapezium is a closed figure. We know it is a quadrilateral too. What is its property? It is specialty. Yes, it is a pair of opposite sides are parallel. Look at here, the two parallel sides are given in the length A and length of the larger side is B. They are parallel, and this perpendicular line is given H, that is the height of this trapezium. Now we discuss what is the area of this trapezium. Area of trapezium is half into 1 by 2 into H into A plus B. What is this? Area of a trapezium is half of the height into sum of parallel sides. Now we discuss a question. Look at these questions. Find the area of these following trapeziums. Look at the first one. Here the parallel sides are given 7 cm in length, then the other one 9 cm in length, and its height is 3 cm. So we know here height of the trapezium 3 cm, length of the parallel sides are 7 cm and 9 cm. Area of trapezium is half into height into sum of parallel sides, right? So here half into height is 3 cm. So 3 into sum of parallel sides is 7 plus 9, that is 16, right? So half into 3 into 16. So the answer is what? 24 centimeter square. Now look at the second question. This is a trapezium, this is also a trapezium. Here these are the parallel sides, 5 cm and 10 cm in length. They are the parallel sides, and height is this way. So height is here 6 cm. Then how do we do this? Height is 6 cm, length of parallel sides 5 cm and 10 cm. Then area of trapezium half into height into sum of parallel sides. What is the sum of parallel sides here? 15, right? 5 plus 10, 15. So half into height 6 into 15. So it will come up to 45 centimeter square. That are two questions for finding area of trapezium. Now we look at another formula to find area of a general quadrilateral. General quadrilateral means this quadrilateral has no specialties. All the sides are different in length and all the sides are not parallel sides. There is no parallel opposite sides, all are different. Okay, how do we find then it is area? To find the area, look at this is a quadrilateral ABCD. To find the area, we divide this into two triangles by drawing the diagonal AC. Now we have to find area of these two triangles, then add them, then we will get the area of this quadrilateral. That is the idea we apply here. So height of this triangle ADC is H1, right? Height of this triangle ABC is H2. What is the base of the triangle ADC? AC. The diagonal AC is the base. What is the base of this triangle ABC? Then its base also AC. AC is the common base for these two triangles, and heights H1 and H2 are different. Okay, so while adding these two areas, we will get this diagonal in common. So the area formula of this area of a general quadrilateral, you will get like this: half of diagonal, half of AC into h1 plus h2. How do we say that? Half of diagonal into sum of heights. Okay, just go for an example. Look at this. Here the same general quadrilateral. Height of the first one ADC is 3, base is 8. Then height of the triangle ABC is 5 cm, base is the same 8. Now half of height, half of diagonal, right, into sum of heights, that is half into 8 into 8, that is half of 8 is 4, 4 into 8, 32 centimeter square is the area of this general quadrilateral. Now we go for another formula. If we apply the area of general quadrilateral, that idea if we apply in the rhombus, look at this is a rhombus. Okay, if we consider these two separate triangles, this one is the height and this red one is the base. This height, if we divide this red diagonal, the diagonal in red color, into two parts, that are the heights of these two triangles, and the green colored diagonal is the base. Okay, so one important point we know, one property of diagonals of rhombus we already know. What is that? Diagonals of rhombus bisect each other. Okay, while adding these two heights, we will get the diagonal A and this diagonal B. So after finding the area of these two triangles together, at last you will get like this: area of rhombus is half into A into B. What is that? A into B? Yes, multiplication of these two diagonals. So half of the product of diagonals. Simply the area of rhombus is half of the product of diagonals. Now we just take an example. This is a rhombus with two diagonals 8 cm. This green color diagonal is 12 cm. Okay, then what will be the area? Area of this rhombus is half of the product of diagonals, half into 8 into 12. So answer is 48 centimeter square. Now we do a word problem for trapezium. Okay, look at this question. The shape of the top surface of a table is trapezium. Okay, this is a table and its top surface is this trapezium shaped. Find its area if its parallel sides are 1 meter and 1.2 meter and perpendicular distance between them is 0.8. So perpendicular distance between the parallel sides means height is 8.8 meter. Then we know what is the formula to find area of trapezium: half into height into sum of parallel sides. Okay, so one parallel side 1 meter, the other is 1.2 meter, then height is 0.8 meter. Area of the top surface of the table is half into A plus B into H. That means H into A plus B are same. Half into sum of parallel sides 1 plus 1.2, that is 2.2, right, into height 0.8, then half into 2.2 into 8. So answer up to 0.88 centimeter square. Now another question for trapezium. Mohan wants to buy a trapezium shaped field its side along the river is parallel to and twice the side along the road. Its side along the river is parallel to and twice the side along the road. If the area of this field is 10,500 meters square and the perpendicular distance between the two parallel sides is 100 meter, find the length of this side along the river. Okay, so this is the field. At one side there is a road, at the other opposite parallel side there is a river. Then distance between the two sides is 100 meter. Okay, here one more point is given. The side along river is twice of the side along the road. Okay, so look at this. Here perpendicular distance is, that is height, 100 meter. Area of trapezium is given already, 10,500 meter square. Let the side along the road be x, so this be x meter. Then this side is twice of this given in the question, so 2x meter, right? Yes, area of the trapezium field is half into sum of sides into height. So area is already given, 10,500 is equal to half into sum of parallel sides into height. Then sum of parallel sides become x plus 2x become 3x. Then half of 100 becomes 50, right? Then here we will get 150x. 150x is equal to 10,500. At last x is equal to 70 you will get. 70 is the side along with river is 70. Sorry, the side along with the road is 70, so the side along with the river twice of 70, 140. Okay, that is the answer. Side along with the road is 70. Here is a mistake. Then the side along with the river is twice of 70, that is 140, right? That is a question for trapezium. Now look at this another question. The floor of a building consists of 3000 tiles which are rhombus shaped and each of its diagonals are 45 cm and 30 cm in length. Find the total cost of polishing the floor if the cost per meter square is 4 rupees. Look at this. This is the rhombus shaped tile. Diagonals are 30 cm and 45 cm respectively. We know what is the area of the tile, half into product of diagonals, right? So total number of tiles is used to 3000. 3000 tiles is used on that floor, right? Since tile is shaped of rhombus, diagonals are given 45 and 30 cm. So each diagonal D1 and D2 we have taken 30 and 45 centimeters respectively. So area of one tile is area of the rhombus, half of the product of diagonals. So at last we will get 675 after multiplying. That is area of one tile. So we have area of 3000 tiles to find. So 3000 tiles area, we got this answer. Okay, 20,25,000 centimeter square. But the question is given in meter square. 1 meter square polishing cost is 4 rupees. So first we have to change this into meter square. How do we change centimeter square to meter square? By dividing down 10,000. Okay, so the answer comes at last 202.5 meter square. So 1 meter square costs 4 rupees. So 2.2.5 meter square cost 4 into 2.2.5. So the answer comes 810. rupees.